I'm guessing we have to get this signed and turned in by
Yes.
tomorrow.
So, tomorrow we'll have a test over this. You'll need to read all the rules. So make sure you read all of this because we will have a test over it. Get this signed and back to me as soon as possible. I need this before you can enter the lab. And today we're going to go over lab safety. So in chemistry, it's the most important thing. Because in this class, we will be using the lab. And we'll be handling a lot of dangerous chemicals. So why is lab safety important?
To keep us safe.
I have been in some college labs where we had dangerous chemicals. In college, you handle dangerous chemicals. You handle a lot of dangerous chemicals. You are considered adults. You're supposed to be able to do chemistry. I had a girl.
Did she catch her hair on fire?
No, just listen. It's a really good story. Just have to listen.
So, if you came in, sat down at your desk, and you noticed like salt or something on your desk, what would you do?
Don't touch it.
In your desk, you're not thinking clearly.
In here, like in here. Yes. If you come to class and you see it on your table.
I would probably let the teacher know.
No, you would not. We
Almost
want
every single person would do exactly what I would do. Like right now, I have some paper fragments. I would do this.
Well,
It's
if it was a
instinct.
chemistry class, then yes, I would ask
Yes.
the teacher.
Inside the classroom, your instinct is to wipe it away. So, standard thing. She came into the lab, saw some white powder on her thing, didn't think anything of it, wiped it away. Do any of y'all know what acidic salt is?
Oh God. They don't sound good.
So, have you ever seen The Mummy?
Yeah.
Where they open up the crypt and this salt or sand that gets blasted at him, and then you see his skin dissolve? Well, that's acidic salt. It's acidic salt solution. One, that's Hollywood. It really doesn't do that in real life. It can, but usually... So an acidic salt is a salt that when mixed with water produces acid. By itself, the salt isn't acidic. But when mixed with water, it produces acid. Now your skin has a little bit of acid, or a little bit of moisture on it. Or mostly water. So if you get some acidic salt on your skin, because there's so very little moisture, it's not going to do much at first. As you keep it on your skin, eventually it's going to start burning, and if you don't wipe it off and get it off, it's going to eventually burn you because there is some moisture in your skin. It's going to produce acid. You can go wash it off and dilute the acid and get it off pretty easily. So, the person who was in the lab before didn't clean up properly, and it's led to this. However, she took her goggles off and rubbed her eye. Your eyeball has a lot of moisture in it, a lot of water. Your eyes cannot be left dry. It is constantly, every time you blink, you're constantly adding water to your eye.
Don't watch no butts. Pay focus to TV. Boom.
So, the acid, as soon as it touched the eyeball, immediately turned into highly concentrated acid. The acid didn't just slowly start dissolving her eye, it started rapidly burning. She immediately screamed at the top of her lungs in pain, covering her eye, as her eye was literally being dissolved away. Luckily, our lab professor knew what was going on and knew lab safety protocol. He quickly got everyone to back up and grab the student and brought her to the eye wash station, shoved her head under it, and started immediately applying the eye wash. He did this for 15 to 20 minutes, making sure that the acid was removed from her eye. She lost 90-95% of her vision. Her eye eyesight was gone for about 2 or 3 months. Because the professor acted so quickly, he was able to prevent a lot of damage. There was still permanent damage. I think after 6 months, 8 months, she got about 80% of her vision back, enough to where glasses can easily correct for her. She did get permanent damage to her eye, but she didn't lose her complete vision. So the importance of this is to know and recognize dangers in a lab. This was a lab experiment that we were doing that was completely safe. There was no risk involved in that day's lesson. However, the previous students had used a dangerous chemical and didn't clean up. So even though we might not be doing anything dangerous in the lab, you do not know what chemicals were used before. Maybe we didn't clean up yesterday. Maybe I went in there and started playing around. It happens. There's a lot of chemicals in there. And it could be something spilled. So we need to know how to react. Because the professor had acted and knew the protocol on how to remove the acid from the eye and acted so quickly, she basically kept her vision, even though it was slightly determined. I think after a year or two, she probably could have got most of her vision back. Once your eye is actually attacked, what happens if you get cut? You get a scab afterwards. And how long does it take a scab to fix? Kind of a long time. When you get an eye, you'll have a scab of your eye. Basically, same thing. It's slightly different. It's different tissue. But if you act quick enough, yes, you'll temporarily lose your vision, but you can end up saving most of the tissue in your eye and not actually lose your material if you act quick enough. So, on lab days, I will tell you a day in advance. I'll tell you before lab when we're having it. When you on lab day, so if we're having a lab tomorrow, I say we're going to have a lab tomorrow. Do not go into the lab. You're going to come in here. You do not go into the lab until I give you permission. Another thing, when you go in the lab, I will have things set up. I might have beakers full of water or some clear mystery liquid. A lot of the chemicals are clear, odorless, and look like water. They may not be water. Do not go into the lab and immediately start touching things. I will give you instructions on what to do. Make sure you follow them. If you have any questions or do not understand something, ask. Also, do not mix chemicals together. We could have one chemical that is relatively safe, another chemical that is relatively safe. However, if they mix together, they produce a poisonous gas or explode. So do not mix anything together that you're not told to. Also, keep all backpacks in the classroom. You don't want to be tripping over them in the lab. On the first day of lab, I would point out everything where they're located at. I'm sure you've been in the lab. If you haven't, I will point them out. Eye wash station is far away over there. On the other side of the room, first aid is also over there. Safety goggles and aprons are required if we will be using heat, chemicals, or glassware. Another thing to think about, if you're temporarily blinded, if you can't see, how would you find the eye wash station?
Mr. West? You hear me over there, Mom?
So I worked in some labs with some of the most scariest chemicals in existence. Chemicals that I was afraid to even touch the bottle next to it, just in case there was some contamination. Whenever I handle dangerous chemicals in the lab, I always have in the back of my mind where I'm at and where the safety equipment is relative to me. Because if something were to happen and I couldn't see, I need to be able to feel blindly and walk toward the area. I need to know where my position is. So, have you ever had a water gun squirt into your eye?
No.
Have you ever gotten to the shower and looked up and had water splash in your eye?
Nope, I won't even open my eyes underwater.
Having water spray into your eye is uncomfortable. Your natural instinct is to keep your eyes shut. Unfortunately, keeping your eyes shut does not do anything to remove whatever chemical has been introduced to your eye. You're going to have to sit there and force your eyes open. You're going to have to keep it open for 15 to 20 minutes as water is splashed in it. It's going to be very, very uncomfortable. You are not going to enjoy this experience, but if you want to keep your eyesight, you must do it. Every second that it's not washing out the chemical is longer for it to react to your eye. Safety shower. If a chemical is spilt onto you, and even if it's relatively safe to get a drop or two on you, if there's a large spill, you might need to be required to go into the shower, the safety shower. You're going to have to stay in there, and it's going to make you completely soaking wet. My goal is if we need to eye wash or shower, hopefully it will never occur, but I will have all the students that aren't affected leave, go into the hallway and go get the principal and nurse, and go into, I'll tell y'all to go into the hallway, so to give you some privacy, because you're basically going to be under cold water and have chemicals being washed off of you. You do not want to have major chemical burns. They will completely scar you. But other than at the end of the year, I have some chemicals I will demonstrate. You will not be touching them, but there is a small chance. I'm going to do them under fume hood. There'll be glass, and my hands go underneath, but the bottle could fall over and splash down and get on your pants leg. One chemical in particular, sulfuric acid, that I have will go straight through your pants like no problem and actually start going through your skin.
You want battery acid stuff?
Yes. Fire extinguisher. If you've never used one, basically pull the pin and compress the handle while having the hose pointed in a safe direction. Note, how fire extinguishers work is they starve the fire of oxygen. If you have some wood and a giant big bonfire, you don't want to spray it directly at the fire. You don't want to put it in the middle of the fire. You want to spray it on the wood, the base of the fire, whatever is burning, whatever is causing the fire to be there. If you spray it directly at the fire, and as soon as you run out, the fire will start back and continue burning. You want to put the source that's burning out so the fire doesn't come back. First aid kit, band-aids and burn cream. If you get burned, burn cream contains lidocaine, which is a pain reliever. You probably, no, that's Novocaine or somewhere. But it'll reduce the pain if you ever gotten burned. It burns hurt. But also, most of them have some chemicals in there to prevent scarring. Burns usually cause scars, so it'd be good to put burn cream on it. Fire blanket. If there's a small fire or a person is on fire, you grab the fire blanket and try to smother the fire out. So if someone's clothes catch on fire, grab the fire blanket. First, drop down and roll. Then someone grabs the fire blanket and they start patting you down. Obviously, you don't put it around someone's head and suffocate them and put your hand blocking their mouth. But hair is extremely flammable, and you would want to smother the fire out in that scenario or go under the shower. Exits, know where the exits are when you enter the lab. So when would you use a fire extinguisher?
When there's a fire.
Depends.
If it's a small fire, you could probably put, and depends if it's electrical fire.
Yeah, so there's different types.
On what type of fire it is.
There's different types of fire extinguishers. Some are rated to do electrical, But so if I caught on fire, what would happen if you sprayed a fire extinguisher on me?
It's gonna hurt.
Wouldn't it also suffocate you because it would block your oxygen?
Yes.
And that's why they do the fire blanket so that.
Do not use a fire extinguisher on a living person. Most of them do CO2. The whole point of a fire extinguisher is to remove oxygen from the air. Usually it's temporary, but a few going about 30 seconds or a minute without oxygen could cause you to lose consciousness and could hurt you. You shouldn't be spraying anyone with a fire extinguisher. It could cause you to run out of air temporarily. Fire blanket, so if I had a whole bunch of beakers, small fire, don't grab the fire blanket and throw it on, causing all the glass and chemicals to break and spray everywhere. Fire blanket should be for small fires, usually on a table with no glassware, or on the ground, like so you drop some alcohol and the floor catches on fire if it's small. Also, if the entire room is on fire, do not grab the fire blanket and go corner to corner trying to get it off. Only for small fires. When would you use a shower to put out fire?
On your body?
So if your body's on fire and fire blanket's not quick enough, run under a shower, turn it on, I'll get it off. Also, chemicals. Chemicals can start fires. You mix two chemicals together, they touch your shirt, they catch on fire. If you use a fire blanket, if it's a chemically caused, and you can put it out, and as soon as you remove the blanket, it recatches on fire because it's a chemical reacting with your clothes to catch it on fire. In that case, if it's a chemically caused fire, you need to use the shower, and you only do it if it's your own fire. So, some chemicals are relatively safe to handle, however, are poisonous. For example, hand sanitizer. You all have probably been using hand sanitizer. It's relatively safe. How it works is it destroys the cell wall. Bacteria and viruses have like a cell wall. Animals such as us do not. So whenever the alcohol in the hand sanitizer goes onto the skin, keeps you nice and safe, but it kills any bacteria and germs, viruses. However, if you were to drink it, it is poisonous. Actually, the CDC in the last few weeks, I think like 2 weeks ago, has released an issue. So everyone's trying to get hold to large supplies of hand sanitizer. The companies have been failing to meet safety regulations. So in the production of alcohol, you usually end up making something known as methanol. Methanol and ethanol is the drinkable alcohol, are chemically similar. In all aspects, they're almost the same thing, except for methanol is highly poisonous. A little bit of it ingested will cause permanent blindness. If you take too much of it, it will kill you. It's a very small amount of lethal doses. Even a small traces of it can cause permanent blindness. I believe Trump went on and suggested people may try to get rid of COVID by ingesting or ejecting.
At this time, any freshman last name beginning A through H, please come to the office if you need a schedule change. Freshman last name beginning A through H, please come to the office at this time if you need a schedule change.
Anyway, a lot of people who have drinking hand sanitizer have had eyesight problems, and some have died because
I tasted it when I was younger.
extremely bad.
A kid told me that. I've also sprayed perfume on my mouth.
My point is there are some chemicals that are safe to handle, relatively safe, but the tiniest amount of it can be quite poisonous and lethal. So do not bring any food, gums, or drink inside because they might be contaminated. Also, before you leave the lab, wash your hands. Like I said, you do not know what chemicals have been used previously. No matter how small the accident is, report all accidents and spills to me immediately. If you cut yourself, I want to know. If you spill anything, like I said, some chemicals are relatively safe, but if you mix two safe chemicals, they can make a more dangerous one. So if you spill something and then later someone spills something else, I need to keep track and see if there's going to be some problem. For example, bleach. So bleach is relatively safe, right? And it might cause us a rash if you get on it.
Yeah, I'm allergic to bleach.
But like you would say, bleach is relatively safe to handle, right? Relative, and you could be allergic, but
I'm allergic to that.
ammonia is relatively safe, right? Used to disinfect and clean things. What happens if you mix ammonia and bleach together?
Something called like fumes or toxic.
Produces hydrochloric acid. The fumes are there's a lot of things. Like if you mix bleach with other like cleaning supplies, if you mix bleach with almost any other cleaning supply, it produces hydrochloric acid. And the fumes and chlorine, it produces chlorine. Very dangerous to mix bleach, and mostly like soap. You can mix soap and bleach together. Again, it's something very common. Most people have bleach in their house. Some people clean things with bleach, and then if you come around and clean something with soap or ammonia or other things, you can be producing a very dangerous gas. So I need to know if there's any spills. Also, broken glass. Do not pick up broken glass with your hand. Use a broom. In an emergency, call me. There might be some preserved biological materials. I know we have a pig's heart in there.
A little more.
Be respectful. They were living things. Don't be playing with the dead bodies.
Didn't you only used to have baby sharks?
I believe so, yes.
Can you bring it out here?
They were so cool.
If we have any living ones, obviously don't harm them. Also, at the end of lab, when we're finished, you're not allowed to leave. You need to clean up. My labs do not go to bell. So whenever you're done with your lab, clean up, and when everything's clean, tell me, then I will tell you, you can come back to the regular classroom. Make sure you push your chairs away and the lab area is clean. Dispose of any lab materials properly. So, when I was in high school, I graduated in 2007. My class, it was not my class period, but the period after mine. 2 people had dumped some chemicals down the sink. It was during either 7th or 8th period, and so it wasn't anything noticeable at the time. I believe what they dropped was baking soda and vinegar. You ever done the volcano experiment?
Yeah, no, but I put that on my feet to get the skin off.
So it produces a lot of gas, and the pipes underneath the school burst. Next morning they come in, the bathrooms are all flooded, and we had to shut down the school's water system for 2 weeks. No bathrooms for 2 weeks. No water fountains for 2 weeks. Couldn't go to the bathroom. Couldn't drink any water. It was a rough week or 2. So get any permission before you flush anything down the sink. Broken glass should not be put in a garbage can. We do not, so these bags are really thin. Glass is very sharp. If when Miss Bambi gets the garbage, glass is going to just rip through and have broken glass everywhere. Put it in the cardboard box marked sharps or glass. Also, I take lab safety very seriously. No horseplaying or fooling around. If you horseplay in the lab, I will ban you from the lab for the rest of the year. You will go to either ISS during our class period or the office, and you will sit there and write a very long paper detailing what you should have learned, what the lab was about, what was its point, and I will grade it, while everyone else probably gets a free 100 for participating in the lab.
Any freshman students that need a schedule change to come to the office at this time? If you're a 9th grade student and you need a schedule change, come to the office at this time.
So again, wash your hands before leaving. Fire drills. So, if there's a fire, if the fire alarm's going off, what should you do? Exactly. Do not leave. Unless you see smoke and fire, you are not allowed to leave. Unless you feel your life is in immediate danger. This building is flame retardant. What that means is that it slows the rate of fire. If this room were to catch on fire right now, this school would not burn down in 5 minutes. These walls, carpet will burn. We have drywall. Drywall is not that flammable. The ceiling tiles will burn, but for the most part, the tile floor won't catch on fire. We now have tile up there. If a fire breaks out, it's not going to spread very fast. So unless you see smoke bellowing, you will not be allowed to leave immediately. Another thing is if we have gas, if we're using the Bunsen burners, and there's a fire in this room, or home ec's cooking a cake, and we have gas running in the lab, what do you think will happen if we keep them on and evacuate?
It's going to
It will explode. What could have been a simple fire has turned into a gas bomb.
But you would be the one to quickly turn those off, right?
No, we'll check it. Again, you are not allowed to leave until I say we can leave. Another thing, let's say that we're in this classroom. We're in this classroom, we're not in the lab. Fire alarm goes off. You will not leave outside this door until I've given you permission. Unless there's smoke bellowing in and we see fire somewhere. Reason why. So do not leave this room until I have given you permission, because we discuss this every year before students come back. As you may be aware, there are a lot of school shootings in America. One of the number one things we've been seeing is a lot of school shootings. They come up to the building, they make it past the hallway, and they go and pull the fire alarm. Everyone's reaction is to immediately walk out into the hallway. For a shooter, that is a mass of targets walking in front into a packed hall.
Oh, in a single file line, just for him. Sorry, but whatever.
So, my plan is, you'll make a single file line at the door. Then, giving me some space to open the door, I'm going to start closing the door next week. And I will stick my head out, look and see if it's safe. I will also let a few other classrooms go first. We will evacuate toward the cafeteria and take a left. So goggles and aprons need to be worn if dealing with glassware, or fire, or heat, or chemicals. Any of y'all wear contacts?
I sometimes do, but it's only in one eye.
Alright. So, have y'all ever played with super glue?
Yeah, I used to stick it in my fingers and then peel it off for like a week. It was fun.
Do y'all know how super glue works?
No. It gets hot though.
Yeah, that's a chemical reaction. So, cyanoacetate is a chemical, and it requires water to work. Cyanoacetate by itself doesn't glue anything. That's the reason why it's liquid inside the bottle. That's why it doesn't glue the bottle to itself and harden up. As soon as it's exposed to moisture, it changes chemically, producing some heat, and bonds. It's also highly volatile. What does volatile mean? It means it evaporates very quickly. That's why if you were to take open up a bottle of super glue and put a single drop on this notebook, then close it up, you will see later a white powder around where you put that drop. You will also see a white powder on the bottle. That is because some of the super glue has turned into a gas, risen up, and fell back down around it. It is slowly evaporated. Have you ever had your eyes be really irritated after using super glue? If you have, it's because, one, you were probably standing over something. The gas is going to rise straight up. So while you're super gluing, the gas is rising up. You shouldn't super glue like that, you should use super glue in an open area and away from your face, because the gases the vapors are going to rise up. Your eye, like I said, is mostly water, so the super glue is going to bond and stick to your eye. A little bit's not going to do anything to your eye. Your eye is going to be irritated, it's going to be scratchy, nothing's really going to happen to your eye. Unless you have contacts. If you have contacts, you can super glue the contact to your eye. So make sure you wear goggles if you wear contacts. There's also some chemicals that can melt the contacts. If you have an option of not wearing them, on lab days I wouldn't wear them. But if you do wear them, it's alright. Just make sure you have
If you
goggles.
let me know the day before,
Yes.
I won't wear them. Because I wear them a lot of times during softball season.
Yeah. Like I said, you can also just take them out too, or
Yeah.
but you can wear goggles. I just want I want you to be mindful that there is a risk. And again, I analyze every time I have a lab. I think about what these chemicals can do and all these issues. Clothes and hair. So hair has a lot of static electricity.
It's also highly flammable.
Also highly flammable. So if you lean over a table and your hair is down and it touches the table, it's like a magnet. It will pick up all the chemicals, any dust on the table. Hair that gets anywhere near anything is really bad at attracting and holding onto chemicals. Some chemicals, like I said, safe to handle temporarily. But like acetone, fingernail remover. So if you spill some acetone on your skin,
Poof, it's gone.
nothing really bad will happen.
It's gone now.
Now, if you take some acetone and hold it in a cup in your hand and hold it for about 5 minutes and then dump it out, you'll notice your skin has turned white. It has started killing your skin cells. A small amount for a brief period of time, not a big deal. Long-term exposure to a chemical can be different. Your system is kind of resilient, but so if you quickly wash it off, it's not going to do anything. But if you have something in your hair, it's constantly on your body, rubbing your shoulders or neck for several hours, it could cause you to break out in a severe rash. Long sleeve shirts and sweaters, same thing, because you're going to be touching the table. If you have a long sleeve shirt and a sweater, roll them up. If you have hair, it needs to be tied back. If it's long enough, tied back behind your back. Eye wash for at least 20 minutes, 15 or 20. Smelling and touching chemicals. So when you smell a chemical, y'all probably all seen the wafting method. So when I was in speech class, being a science nerd, I decided to demonstrate the electrolysis of water. The electrolysis of water is taking H2O and using electricity to rip the H2 and O apart. Basically, I'm taking water and producing hydrogen gas and oxygen gas. Water is not conductive by electricity. You cannot run electricity through water. In order for it to conduct electricity, it needs electrolyte, something to make the water conduct electricity. I use the most commonly available electrolyte, table salt, sodium chloride, sodium and a chlorine atom. Running electricity through it causes the chlorine atoms to break off and produce chlorine gas. It's not that dangerous, it doesn't produce enough, but when chlorine enters your lung, it produces hydrochloric acid. Hydrochloric acid will eat through your lungs, dissolve your lung tissue, and make you where you can't breathe. It was used tremendously by the Nazis in World War II and World War I, killing millions of people. It's a really bad chemical. But in this experiment, it wasn't producing that much. You can also smell chlorine on pools. You add chlorine to pools and you smell that chlorine smell. Again, it's not enough to really hurt you. Because the water in your lungs will dilute it enough that it doesn't do anything. However, so I commented when I was producing it, I did this, and you can smell the chlorine. It smells like a swimming pool. My professor leaned over, who was standing next to me because I was giving a speech in front of class, and put her nose to it and took a deep breath. What happened to her is her lungs quit working for a few seconds, and she stumbled backward and her lips went blue. She almost passed out and fell. Luckily, I had the deal on the table. I kind of grabbed her arm and kind of helped her. She lost consciousness for about half a second or a second. And if you go over to a chemical and breathe it in, and that happens to you, and you lose consciousness and you fall and hit the back of your head on a table, bust your head open, it could lead to some problems.
You don't catch us when we fall.
Well, it depends on if you're.
Ryan, you better catch us.
Well, you're getting out of chemistry, so.
Oh, yeah. Ain't nobody got to catch me where I fall.
So broken glass, don't touch. Has anyone ever been electrocuted?
When
Oh,
was
yeah, I
younger-
did. My lamp electrocuted me. It didn't hurt that bad.
I've been shocked by
When I
light.
was younger,
Oh, and a cow fence. I kept our cow fence and almost died, but it's
I
awesome.
ended up sticking like a dime in like one of those sockets.
So,
I was a little kid.
Our electrical was done, and I flipped on a light switch.
Nuh-uh. Worse.
cattle fences are right at the limit of being, I don't know, it's hard to say which is worse. So the mains in your house and at school, they'll kill you in like a minute or two. A cattle fence will probably take like 30 minutes, 45 minutes to kill you.
Yeah,
So I don't know which is worse. So if you ever taken anatomy and physiology, how your muscles work is your brain sends a tiny electrical signal down to your muscle. It causes it to contract. So if you were to take a dime and put it into an electrical signal, you take a dime, touch it, your hands go to form a fist. You go and touch it like this, your hands go, so you probably don't even realize this happens. You touch it and your hand just immediately contracts, and then you pull it back and go, gosh, God dang, it hurt. Now what would happen if you touch a wire like this?
You're gonna grab it, it's gonna.
You're going to make the most hardest fist you've ever made. Your fingernails are going to be cutting into your skin. You are going to be locked. Not only that, you're going to be paralyzed, unable to move. If you were to touch the electrical main, not only will you be paralyzed, you'll be sitting there staring at your hand as it is turning black and charred and your body is smoking. Your hand is going to be producing smoke. You're going to see sparks flying. You're going to be seeing your hand probably catch on fire. The entire time you are paralyzed. Your entire body is in the most intense pain you've ever felt in your life.
How does someone rescue you from that?
I'll get into it. What do you do? So this being killed by electricity in this scenario is extremely bad. So what do you do if you see someone? Yes.
My dad messes with electrical a lot, so my mom is real finicky with it. So she'll always have us like get a stick
Mm-hmm.
or a wooden broomstick and be standing right there just in case if he does get electrocuted and like you hit the arm away.
Exactly. So
You can't throw him over the head so he'll let go.
I'm getting here in a second. The number one thing is grab something that doesn't connect to electricity and try to hit the arm. Like a broom, like a yardstick. Don't grab something metal. First of all, the only way electricity can kill you, one, if it's cooking your body, it's like being in a hot oven, you're going to die by fire. Electrical fire. You're going to heat up and boil. That's a very slow and painful death. The other way electricity kills you is if it runs through your heart. Now imagine someone's holding it, they're being electrocuted, and you come over here to push them off. You grab them right here.
Oh, it's just
You'll be electrocuted as well.
The electricity will go through their chest and they're dead. You just killed that person. Now their muscles are being electrocuted. They're not going to fall down to the ground. They are locked in place, but they're dead. They're still being burning. Your hand is touching them. You are now being electrocuted yourself. A cattle fence doesn't produce enough electricity to kill two people. These electrical wires are. So if you go up and try to push someone, you will potentially kill them. And you will probably be in the exact same situation they are. You have just now taken the place, and now your life is in risk while you're holding on to them. So because you will grab a hold to their shoulder and walk down. So, best strategy is to grab something non-conductive and break their hand away. The next strategy is some sort of pushing away. You do not push. The best way of doing it is a run and tackle. Because as soon as you touch them, you are going to be paralyzed, and if you're running fast enough in like a football tackle situation, as soon as you paralyze up, your momentum is going to carry you forward and you will break them off. And in the event that their hand is sticking on too much and you don't do it, you can get up and try again. The body is very resistant to electricity, but and especially contact with clothes, but resist somewhat. So I tell you this because if you have something, I know this is USB, but if you have like an outlet to the wall, you should not grab hold to the cord and pull it out. There's a chance this is made of cloth, this can rip and tear. As you pull it, it can remove, and you could touch and hold to the wires. For the plastic one, same thing. You can grab it, and you do not want your hands like this. You want to grab the tip of it and pull outward. If my hands were to squeeze, nope, I let go of it. We will be using probably microscopes or something, or using electrical heating and plugging it in. So always make sure at the very end of the outlet you do that. So glassware. So we use Pyrex glasses. Basically how that works is a special type of glass. The molecules are stretched tightly. Imagine a rubber band. So if I take a rubber band and stretch it, it's very resistant. It wiggles enough that if you hit it, it won't break, it'll just move. It's rubber, but it's being stretched. What happens if you cut the rubber band? It's going to snap and pull back violently. What this means is that the glassware, because of this glass, if it were to break, it's going to cause the glass to shoot. It's going to shoot glass everywhere. It's going to kind of explode. Not that violent as I'm describing, but it can cause some shrapnel to move and fly. And if you get glass in your eye, it is very hard to remove it because it is a clear object and clear liquid in your eye. Surgeons can't really see where the glass is at, and it's hard to find and remove it. As long as the glassware has no chips or cracks in it, it's relatively safe. But if you look at it, inspect it, and see a chip or you see a fracture, you cannot use it because the safety of the glass has been compromised. Hot glassware. So glassware takes a long time to cool off. When you heat it up, you can come back to that same piece of glass and 5 or 10 minutes later, touch it and receive burns. Glass is like water. If you boil a hot cup of coffee, after 5 or 10 minutes, it's not going to cool off. It's still going to be close to boiling point. So keep in mind that glass takes a long time, and you cannot tell. You can't look at glass. So be mindful that if you heat up any glass, don't touch it again. Test tubes. Test tubes should be treated as if they're guns or cannons. When you do chemistry inside of a test tube, there's a chance that it'll blow out all the chemicals out because bubbles can form. That bubbles can trap down, pressure can build up, and it'll start spraying it out. Do not point it toward yourself. Point it away from. Usually point it up. I've seen people take a chemistry tube and they're like, "Well, it's pointing at me. I need to turn it," and they turn it to their neighbor. Be mindful of not just yourself but others. Point it in a safe direction. So what's wrong with this image?
Everything. It's a hot
What
wood.
is wrong with that image?
He got gold on. She don't.
You got the test tube pointed at it.
She's
and
red,
liquid
she
all
must
over
be
the
on
place.
Messy desk. Everything's wrong with this one.
There's a freaking fish. Look.
Oh, that's my friend.
What's wrong with this one?
Drinking something out of it.
Usually half the people say he's smelling something, half say he's drinking it. Again,
She pouring that down the sink. She's pouring
it's
that
chemicals next to your face.
That chemical, he's not,
No, he's pouring it into another beaker.
no, that's not what I'm saying. He might be putting too much of it in there. With
Uh,
the
down
smell.
the sink. You can't-
Also, he's dealing with chemicals.
That's what I
Do
said,
not, you need to be wearing an apron and goggles. And also, don't multitask. If you're pouring one chemical into another beaker, you need to be paying attention to that. And you shouldn't be sniffing or drinking chemicals.
Here. Sleeves.
Hair needs to be tied back. Sleeves need to be rolled up.
Apron, goggles.
She also has glassware, so she needs goggles and apron.
I don't know if this means anything. This thing's too close to the edge of the table. And look at the cord coming all the way around. Maybe it's going to the other side of the door.
No, that's going around to an electrical outlet on the eating in the lab.
So eating.
Oh, he like, oh girl, looking at me, my apple. I helped you. You should have did this.
So I don't see any glassware near him, so he doesn't have to wear goggles, but he is eating in the lab, and again, you can pick up chemicals.
Ew.
What's wrong with this one?
That's two.
No? There's only one thing I see wrong with this picture.
He's not paying attention to what he's doing.
Yeah, they're both paying attention.
They have long sleeves, but they are rolled up. They
So?
don't have goggles or
So
aprons.
he's holding glassware. She's, I think it's a she, is doing a Bunsen burner, so that's flame. Flame, glassware, both need goggles and apron. All right, that's it. So we're gonna have a test tomorrow.
Why?
Make sure you read over and get that signed.
So it's just gonna be me, you, Paul. In this class.
You're not saying? No, it's perfect timing.